So check, and then if you have any questions, always refer back to the notes. So in 5.4 here today, we're going to focus on here, it says two-way tables and Venn diagrams. So we're going to start to take a look at probabilities when we're starting to compare more than one type of variable, or you can think about those variables as events. Okay? So as it says here, probabilities involving two events. When you have, or when you're looking at basically probabilities with two events, there's a couple ways that you can display all your possibilities, okay, or your sample space. One of the ways is by doing a two-way table. Okay? So to show you an example where this can occur. It says here, students in a college statistics class wants to find out how common it is for young adults to have their ears pierced. They record data on two variables, gender and whether the student had a pierced ear, for all 178 people in the class. The two-way table below displays the data. So the two different events are their gender, male and female, and whether or not they have pierced ears, yes or no. And you can see how many of each that we actually have here. Okay. So it says, suppose we choose a student from the class at random. Find the probability that the student has pierced ears. Okay. So, how many students in this two-way table actually have pierced ears? Okay, so we look under yes, yeah, 103. So that's our top number. What's our bottom number? Okay, yeah, the total number of students, 178. So you can leave this as a fraction. If you're one who likes to put it as a decimal, that's just fine. Okay, I know my calculator's open. I purposely didn't want to shut that down. But if you want the decimal, 103 divided by 178. Go ahead and hit enter, switch it to the large screen. So 0.579 is it as a decimal. So then, just keep on doing the process here. On the second one here, it says, is a male with pierced ears. So the person has to be a male and with pierced ears. So how many males have pierced ears according to this table? Okay, 19. And we're still doing it out of the class, 178. So quick decimal, 19 divided by 178. So 0.107. So a little bit more than 10%, but we'll keep it as a decimal since it's asking, ouch, for the probability. Now the third one. This one gets a little bit trickier. Is a male or has pierced ears? How many people qualify for being a male or have pierced ears?
174.
How would you get 174?
There's 90 males.
Okay, there's 90 males.
And then there's 84 females that have pierced ears.
Okay, and there's 84 females that have pierced ears. So you're looking basically at these two numbers, which was 90, and the 84, and you get 174 out of 178. All right, do you agree with Leo? Right. Adrian?
You could also just subtract.
Okay, or you could do the complement and say, all right, subtract the 4 from 178, that would get it to you also. Yeah, I like both those. Both those answers are correct. Here's the one thing that you need to be careful about. Oh, let me give the decimal of this. So we'll do that real quick here. 174 divided by 178. 0.978 if I round. All right. Here's the thing that you need to be careful about here. Okay? And that's what's being emphasized down here. One of the things sometimes students will want to do is they'll want to say, all right, there were 103 students that have pierced ears and there's 90 males. So why didn't I just add those two numbers together? because either they are a male, so that 100, I'm sorry. Okay. Thank you. So we could think about it like this. Why didn't we go, all right, I have 90 males, which would be 90 over 178. And then I had 103 people with pierced ears. Why didn't I just add those two probabilities together? Asia.
Because the 90 males includes the 19 males that you have produced.
Ah, so they actually have something in common. Okay, so if you first add these two probabilities together, you get 193 out of 178. Okay, can you actually have a probability that's greater than 1? No. So that tells you first, well, wait a second, something's wrong. Okay, what we're doing here is, well, if we add the probabilities, that works only if they are disjoint or mutually exclusive. So if they were disjoint or mutually exclusive events, this would work. But are these having, or the person's gender and pierced ears, disjoint or mutually exclusive events? I think you kind of answered that. Are they disjoint? No. They have 19, there's 19 males that have pierced ears that satisfies both quantities. So this is where you need to be careful when dealing with two different events. You need to look at it and say, all right, is it mutually exclusive or not? Because if it's mutually exclusive, this would actually work. But we actually can't do this because they're not mutually exclusive. So when you, in probability, and this is very important, when we talk about the word or, okay, there's a couple things that you need to take into account. Okay, in statistics, okay, the word or means an A or B or both. So you need to take that into account. But, okay, in real life, it just means A or B. Okay? So a statistician, when going to a restaurant, will drive waiters or waitresses crazy. Because when they order like a nice entree and the waiter or waitress goes super salad, the statistician will just simply say yes. Because they'll assume both. Okay? But in real life, what does it actually mean? Yeah, which one of the two? You only get one. You either get soup or you get salad. You don't get both. Okay? But it's important to know that in stats, the word or includes both. Okay? The other part we just kind of talked about a little bit, and we'll see it even more in this picture, in this diagram. When the events are not mutually exclusive, we have to take a look into what outcomes they share. Okay? So what happens is when we have two outcomes, and you can do it when they are or not mutually exclusive, but when they're not, one of the ways we really like to represent visually when we have two events that have shared outcomes is by a Venn diagram. Guys, remember doing these a little bit in Algebra 2? Vaguely a little bit? Way back in like they're actually probably doing Venn diagrams in Algebra 2 here in the next couple days. Anyway, just to help you remember how Venn diagrams work, okay? This circle right here, as it's kind of noted here, might represent a certain event. Here it says event A is male. So everything that's within the circle represents all the males. Okay? So sometimes it might help, I might just write here males. This second circle here represents our second event, which is pierced ears. It's so hard to read it. So what happens is when the circles intersect each other, right, if you were just to add all the males and the pierced ears, it's actually been double counted. Right? So what happens is we have to take that into account. So what happens is when we have two events that are not mutually exclusive, or disjoint, what we do is we take into account one additional piece to the formula. Before, our addition rule was just the probability of A or B was equal to the probability of A plus the probability of B. But since this area is double counted, and that area represents the probability of A and B both occurring, we have to subtract that out. So this is a nice formula that can be helpful to use to find certain missing probabilities. So, if you go ahead and flip the page, we're going to keep on looking at Venn diagrams and how we can use Venn diagrams, okay, to represent different probability concepts that we've been talking about. So, if you look at some of these pictures, okay, it says below are how we can use Venn diagrams to represent concepts such as complement, mutually exclusive, intersection, and union. Okay? First of all, the first diagram goes with the complement. If you look at this particular diagram, notice how you have a circle representing basically everything that happens for event A. The shaded green area, notice here it says A to the C power. That's the symbol notation for complement. Or we can think of the complement as not A, everything that's outside of A. The second diagram deals with mutually exclusive. If two events are mutually exclusive, they have nothing in common. So the circles technically don't intersect. If you actually draw something that intersects, then you would put the number 0 in the place where they intersect. Meaning, if you were to draw a Venn diagram and the events happen to be mutually exclusive, you put the number 0 in their intersection area. So, the third diagram shows you what intersection, the word "and" means. This is the symbol for the word "and." Okay? It's an upside down U. And what it represents is basically what A and B have in common. It's what they share, and only what they share. The last one represents what we call union, or the word "or." So the U is the symbol for the word "or." So notice how it's in just A, just B, or it's in both. So it includes everything there that's shaded in green. So it's just in A, just in B, or in both A and B. So one of the things that we want you to be able to do here today is to be able to go from a two-way table to a Venn diagram and vice versa, and to be able to write probabilities using this type of notation. So we're going to do some examples like that today. But what we want to first do is show you how the notation works. So it says here, in this example, in the pierced ear example, our Venn diagram would look something like this. Okay? So the thing is, we need to make sure that we identify what event A represents and what event B represents. Okay? And that sometimes can be the confusing piece for students. If I look at this circle right here and notice that it has the numbers 71 and 19 in them, A must be representing our males because both 19 and 71 do correspond to males. Now B is not females, okay? It's actually corresponding to the numbers 19 and 84, which corresponds to yes to pierced ears. So we would write something like has pierced ears. Now you might be going, well, where are the females? Where are the people that don't have pierced ears? Okay? They are basically outside the circles that correspond to either males or has pierced ears. Okay? So what you'll start to notice is, like for instance, this 4 is actually outside both circles because they are not a male. So if they're not in this circle, they must be female. If they're not in this entire circle, they don't have pierced ears. Okay? Hence why these 4 would be females that do not have pierced ears, or not males without pierced ears. So what happens is, we'll have all sorts of different symbol notations to help us in identifying where these particular numbers go. Okay? So, for instance, here it says, I'll try to color code this a little bit, the intersection of the two circles. So that's this number right here, 19. Well, in words, what we're saying is they must be males, they must have pierced ears. So it's like saying males and pierced ears. The word "and" means intersect. So we use that symbol, intersect, and then we use the letters that correspond to the two events, A and B. So it's going to be important to identify what is A and what is B. Okay? Sometimes you can use letters to help you signify it. So I might have used, instead of A or B, I might have used M and P, M to represent males and P to represent pierced ears. So now, on the second one here, it says inside circle A, but outside circle B. So it's got to be inside circle A, but it's outside circle B. So it's this area that represents the number 71. Well, if I look at that area right here, it represents all the people who are males, but not pierced ears. So we're saying male and no pierced ears. Notice how I do the symbol notation. Okay? The word no or not is the complement. So I'm doing A intersect, not B. Is that making sense? This is usually the hardest part for students, is doing the symbol notation. Then I'll go through these pretty quickly. Inside circle B, outside circle A. That's these 84 right here. So those are not males, which are females, and pierced ears. So not males, so A complement, intersect B, representing my 84. And then as we saw with the last 4, whoops. Oh, no, I clicked on the color, but it didn't. Oh, okay, let's try this again. Okay. Okay, so this 4 right here are outside both circles, so that's not male not pierced ears, so females, no pierced ears. So that's using the A complement, B complement. Notice how in each of these three, I was using the word and. So I'm using the intersection symbol. All right. You guys ready to do some examples? Woohoo, I'm excited too. Let's take a look at this first example here. So number 1 says this. According to the National Center of Health Statistics, in December of 2008, 78% of U.S. households had a traditional landline telephone. 80% of the households had cell phones, and 60% had both. Suppose we randomly select a household in December of 2008. So, question A says make a two-way table that displays the sample space of this chance process. B asks us to do the Venn diagram. Okay. So, what are the two devices we're looking at? So they own a landline or no landline. And we can look at owns a cell phone, no cell phone. Any of you still know people that don't have cell phones yet? 1, 2, 3, 4, 5, 6, 7. My guess is, excluding grandparents, do you know people that have, okay, are they friends of yours or? Oh, wow. Okay, my daughter doesn't have a cell phone yet, so I suppose babies. How about students that are at least 15 and older? Okay.
I have some friends from South Dakota who don't use phones.
Okay.
Because they all have a close social group, so it's basically like the 90s for them.
Okay, so it's kind of like when I was in
they
high
have
school.
landlines too. Yeah, they still have landlines.
They still have landlines, but they still communicate via home instead of texting each other all the time.
Mr. Hable doesn't have a cell phone.
Mr. Hable doesn't have a cell phone? He's not the only teacher.
Miss Temple doesn't.
Miss Temple doesn't?
Yeah, she was.
Didn't
Didn't she say? Oh wait, no. She
That was
was
last year, bro.
Was that last year? Okay, yeah.
Okay.
Never mind. From what I remember,
Okay.
she did not have. a
Yeah,
cell
there's a couple teachers that I know that still don't have cell phones. But the only people that I know is one teacher, well now two since you said Mr. Hable doesn't. I'm assuming that's correct. And like my in-laws, they don't have a cell phone. Even though we've said we'd get them one, they still don't want one. So there are times where I wish they did.
What if there's like an emergency?
Exactly, I agree with you.
And you don't have to give them like an expensive one, you can get a cheap like flip phone.
Exact, well, yeah. Alright, anyway, the other thing that I'm gonna throw on here are my totals. Because they don't give me every single number up here. They only give me a certain set of numbers. So, let's see here. It says, in December 2008, 78% of U.S. households have a traditional landline phone. So, where does that number go? Tell me when to stop. Does it go here? This goes for the number of people who own a landline and own a cell phone. So where does the 0.78 go?
There.
Oh, beautiful. Because that represents the total number of people who own a landline. So now it says 80% of people have cell phones. Right here. Are you okay with this? Your silence is scaring me. It's making me nervous. Because we know a total of 80% own cell phones. A total of 78% own landlines. Okay? These are where we're talking about both events. What's the only number where they give us where they combine both? 60% had both. So of these values, okay, 0.60. 60% own both. So now, from all the other information, can I figure out everything else? What has to be true about these two values?
You have to add them to 80.
They have to add up to 80, so this should be 0.20. What should these two numbers add up to? So this is 0.18. What should all three of these numbers add up to? Or sorry, 4. They should add up to 1. So if I add up these three, that's 80 and another 18 is 98, which leaves me 2. So if I check here, this should be 20, this should be 22, and these should add up to 1 or 100%. So part of the challenge sometimes is actually calculating out all the different values. What we have to take into account here, okay, is that we have two events that are overlapping. So now, our Venn diagram. I'm going to draw two circles that nicely over-intersect. There we go, switch colors here. So one of these I might just go and put the symbol LL and the letter C to help me know which one represents landline, which one represents C for our cell phones. I tend to start in the middle and work out, but you can start anywhere. What number should go right here where they actually intersect? 0.60. So then when I look at this value, this is landlines, but no cell phone, which would be 0.18. They have a landline, but no cell phone. Here's cell phone, but no landline. What one is that? Yeah, 0.2 or 0.20. And then outside here, no landline, no cell phone. 0.02. Alright, so now C and D. In C it says find the probability that a household has at least one of the two types of phones. Include the correct symbol notation. So I'm looking at, alright, the probability, something involving landlines, something involving cell phones. Now it says at least one of the two types. So, what symbol should I put in between the two? Is this an and or an or? Okay, it's a, why is it an or?
Because it's one or another.
It's one or the other or both, because it says at least one. So it could be just landlines, it could be just cell phones, it could be both. So guess what I have to do to get that actual probability? Add those all up, and what do they add up to? .98. That's good. Almost the entire population can be reached by some sort of phone device. Alright, D. Find the probability that the household has a cell phone only. So when I'm doing this one here, I'm looking at probability. I'm going to involve LL and C again. But I have to do a couple things here. if you only have a cell phone, where is that located up here on my Venn diagram? Okay. So it's just 0.20. But how do I represent that symbolically? What would I first have to put in between here? Is it a and or an or? It's a and,
You gotta do the complement.
but I have to do the complement to something. What do I have to do the complement to? To the landline, because I only want a cell phone, so it's a cell phone and not a landline. Since I only want the cell phones, it'd be the cell phones and not a landline. Now, if I were to ask this question, I could say, you know, what's the probability that they only have a landline? Then it would be landline and cell phone complement. Of course, that probability would be 0.18. So knowing how to write the symbol notation, very important. All right, you ready to try the last example? Oh, that's kind of nice. They actually set it up here for you. So number 2 says, what is the relationship between educational achievement and home ownership? A random sample of 500 people who participated in the 2000 census was chosen. Each member was identified as a high school graduate or not, okay, and as a homeowner or not. The two-way table displays the data. Okay. It says construct a Venn diagram to represent the outcomes of this chance process. So in this case here, it doesn't actually ask you to do the probabilities, but it asks you to do the outcomes. So instead of writing the probabilities, we're going to actually write the numbers, kind of like it was displayed with the gender and pierced ears. So Venn diagram, 2 circle time. So what letter or letters do you want the first circle to represent? Homeowner. So can I go H-O for homeowner? How about for the second circle?
NH.
N-H for what? Well, remember, if this is homeowner, anything outside the circle is not a homeowner. So one event is whether or not being a homeowner or not. The other circle should be,
HSG.
okay, A-H-S-G. So a high school grad. So now, it's going to be these 4 numbers I'm going to be placing in one of the 4 spots. So if I start with top left, 221, where does that number go? Right in the middle, homeowner and high school grad. How about the 119? Homeowner, but not a high school grad. So to the left. Then what 89, okay, goes to the right. And then the 71, yeah, bottom corner. So now, these questions don't ask for probabilities, but they ask how many. So how many people in the survey is a high school grad and doesn't own a home? How many is that? 89. So how do I represent that as in symbol notation? High school grad and doesn't own a home. High school grad is what symbol? HSG. What's the symbol for and? Okay, the upside down U. Doesn't own a home? HO complement. Well, last one. How many people in the survey is not a high school grad and doesn't own a home? How many? Okay, 71, that's the one that's outside both. So how would we represent not a high school grad?
NHS.
Okay, so HSG, when we do complement, I know you're saying not,
Oh,
but since we're using this as our symbol, we'd use the complement. Intersect, doesn't own a home, we just did before. So what's important to be able to do when using the symbol notation is to abbreviate these. You can use A and B that you want. Sometimes you'll be given a problem where it will say A is this event and B is this event. That's kind of nice when they do that.
So the C for complement, is it always when there's a negative?
You can think of the complement as not that event. Yep, that's how we, and what's neat about it is complements, when you add them together, they add up to 1. Or at least when you're looking at the probabilities, not in this case, not the counts. Okay. All right. Any other questions for me? All right, if you want to go ahead and take a look at your CFU packet for 5.4, you can get started on that. We'll stop here.